Okay, so we have to find the coupling coefficient and energy stored in the inductors when t is 1.5 seconds. So let's first redraw the circuit. But first, let's get all the impedance values. So we see W is 2 radians per second. So let's get the impedance. So the resistors we don't really have to do. The impedance for this will be minus 4J. This will be 4J. This will be 2J. This will also be 2J. And then we'll have a dependent voltage source with the positive facing the direction of the red dot. Same goes for here. The value of this one here will be 2J times the current entering this one. So let's do mesh currents. So I1 and then I2. I2 is entering the positive port, so I2 here. And then for this one, it's 2J times the current entering this dot. If you see it's entering from the negative port, so it'll be minus I1, sorry. And now let's find the current values. So for mesh 1, it's going to be, okay, so this is pretty much 40 phasor 0, so it's just 40 degrees. So it'll be minus 40 plus 4I1 minus 4J I1 minus 2J I2. Sorry, minus 2J I2 plus 4J I1. So we see this one and this one cancel each other out. So this is pretty much minus 40 plus 4I1 minus 2JI2. Let's bring the 40 to the other side. And, okay, let's also divide by 2. So this is 2, this becomes 1, this becomes 20. Alright, look good. So now let's do mesh 2. So for mesh 2, it's 2JI2 plus minus 2JI1 plus 2I2. So that's 2J plus 2I2. And let's bring the 1 to the let's bring the I1 to the other side. So plus JI1. I'm going to divide everything by 2, so this pretty much just turns into the following, and divide everything by j as well. So this becomes 1 minus j I2, and it's equal to I1. I'm going to plug that into here. So now we have 1 minus j I1 minus j I2 equals 20. And let's distribute everything. So 2 minus 2I1 minus 2JI1 minus JI2 equals 20. So that's oh wait, these two, wait, no, never mind, these do not cancel each other out. Wait, what am I, hold on, sorry, this should have been I2. This is I2, this is I2 as well. My apologies. So this becomes 1, no, sorry, 2 minus 3J I2. So we just added these two up, equals 20. Get this in phasor format, which is square root of 30 phasor minus 56.309 degrees times I2 equals 20. So I2 is equal to 20 all over square root of 13 phasor minus 56.309. 20 is the same thing as 20 phasor 0. So I2 is pretty much 5.547 phasor 0 minus 56.309. And then now we just have to solve for I1. So 1 minus j times 5.547 phasor 56.309. This value in phasor format, that's just square root of 2 phasor minus 45 degrees. And then we just have to add our magnitudes up and we have times our magnitudes up and add our phasors. So I1 is equal to 7.845 phasor 11.309, and put them in time domain. That's that value cos WT plus 11.309, and I2 is 5.547 cos WT plus 56.309. And then our W was 2, so it's 2 here and 2 here. And then let's get the current when T was 1.5 seconds. So 2 times 1.5, that's 3. But don't add these up yet because this is in radians, this is in degrees. So 3 times 180 divided by pi, that gives it in degrees. So it'll be 171.9. And then let me see what that gives me. I1 you get minus 7.8328 amps, and then I2 it's minus 3.6976 amps. Now we have to find the energy. So it's 1 over 2 L1 I1 squared plus 1 over 2 L2 I2 squared plus M I1 I2. Okay? So you just plug in your I1 and I2, your L's and your M, and then your mutual inductance, and then your L1 and L2 again in here, and you should get 39.23 joules. And then, oh yeah, we also forgot one more thing, our coupling coefficient. So it's pretty much K, M over the square root of L1 times L2. So it's pretty much 1 over the square root of 1 times 2. So it's pretty much just 1 over the square root of 2. So those are our final answers.